So continuing on with the whole question of whether the seas will rise or sink around a given area after glaciation, we mentioned that in some areas you can actually see rising land after deglaciation, and that's because of a phenomenon known as mantle mass flow. And in fact, in areas around Finland, Scandinavia, some areas are rising at 9+ millimeters a year. Very, very fast. That's about a third of an inch or a little more a year. So it's a really fast rise. And I wanted to show you a look at that area. Let's see if I can get this to click here. All right. What that link shows, it brings us to is first of all a map. And it's kind of hard to see probably for you. Probably not used to looking at maps of that part of the world, but we saw this already. It's like the Baltic Sea here, Denmark, Sweden, Norway, and then Finland is what we're talking about. And you can see these lines are the amount per year that the land is rising, and that's 9 millimeters, 8 millimeters. So you can see as you go out, it's less and less in those kind of concentric rings. So there's a huge level of land rising in this area. So this is an area that's rebounding, in other words. So what's causing it to rebound even 10,000 years after, more than that, after the last ice age? That's the real question. How could it keep doing that? Because there's some rebound that happens pretty much immediately when the ice melts, the land rises. But this is something different. It's called mantle mass flow. And here's how it works. Let's just follow A, B, C, D. Okay. So in kind of a unglaciated world, you've got the sea, you've got the continental crust here, the lithosphere, and then the more viscous mantle underneath that can flow slowly. And what happens? We have an ice age period, so that means that a lot of water sticks around on land masses and mountains as ice rather than always melting and going back in every year. So you have accumulation of ice. So as you can see, this ice is sitting here, and in doing so, there's less water in the land, so the sea level is sinking, although you can see a little up there right as it goes close to the land. And there's beginning to be now an elastic deformation. As we follow that a little farther forward with C here, more water transferred onto the land as a big ice sheet, and that huge mass of that pushes down. Remember, the mantle underneath is kind of viscous, flexible. So the more that pushes down now, it's pushing out then from either side the mantle. So this gradual process of pushing it out happens. And so the land itself, as you can see as well, is sinking. Okay. Now, you can kind of see the land is sunk then, it's pushed the mantle away. Now, what happens if you melt the ice? So if we go to D, we've melted the ice. And the ice now being melted means there's less mass, and there's an immediate kind of return of the lithosphere up here. The basic land area is rising now, and that's allowing very slowly the viscous mantle material to flow back in from either side. So in doing that, it means that there's less mantle mass over here as well. Now, of course, sea level also is rising here just in a general way because, well, the water ran off out of the melting glaciers and ends up in the sea, right? So you have that kind of thing happening. So you can see basically the four kinds of steps here of all of this. Now, that's pretty good, but I want to add something too, and this is something that's just on this YouTube. It's not even in the links in the notes. Is this? This helps us understand better what's going on there, and also what's happening in the Northeast United States. So make yourself a note or two. Northeast United States. Why is the coastline sinking? Okay, here's the answer. The last ice age, the mass was pretty much in Canada, into southern Canada, not really much in the United States of the continental ice sheets. Okay, so if you think of this as Canada and this in the United States, okay, so through time, what happens? As you first of all, time one, nothing's going on. And then the ice age starts in Canada, and so it's starting to push down the mass a little bit. The mass mantle flow underneath starts to come this way, and as that mass mantle flow goes this way, it actually pushes the land up here, interestingly, on either side. It's almost like a teeter-totter. This would be the fulcrum right here. So it's tilted and it moves. This land actually goes up even as the mass of ice pushes down here. The bigger mass now pushing down even more pushes the land up even more. So the northeastern United States during the latest ice age was actually rising even as the massive continental glaciers were over the southern part of Canada. Yeah, just like this. So they're rising. Now you can begin to imagine then when the ice disappears. As the ice began to melt in the end of the last ice age, there's less mass now. And as there's less mass, we begin to see a return of this mantle material here. So a massive return of mantle material going now to under where the ice sheet was. As this mantle material flows underneath here this direction, okay, what we end up having here is a sinking of the land, and now upon which all of the ice is gone, that still continues, and there's a kind of mass mantle flow. And you can see that over here, by the way. See the red arrows? I'm off to the right now. This key area here. You can see the arrows there. So this is what's happened. So now, relative to the sea, the northeastern United States, New England area particularly, is sinking. And so sea levels, in other words, relative to the sea, are rising faster than sea level itself globally. So this is one of the reasons why the northeastern United States is so vulnerable to climate change in terms of sea level, because it's already sinking anyway. It makes it worse, okay? This is happening in some other parts of the world too. So what goes up will come down once the ice is gone. So you can see this return of the mantle flow this direction, okay? And at some point it reaches an equilibrium, maybe 15, 20,000 years, and there's no longer mass mantle flow down here in either direction, okay? And this is a graph through time, by the way, that shows all of these as well, if that helps you. So you might want to pause and just kind of think about that a little bit. That's mass mantle flow, and that's why sea level in Scandinavia, which would be like one of these areas here where the ice was actually sitting over it, these areas actually rise even for many, many years, tens of thousands of years. That's why sea level is still rising on and around, say, Finno-Scandia, as we saw on that earlier map. So then one other thing I wanted to show you was the rest of this sea level rise basics notes. One is the melting of alpine glaciers has accelerated. Just know that. It's kind of a fact. Not surprisingly, it's getting warmer. They keep melting, right? This is the kind of unanticipated thing that happened. I've sometimes heard these so-called, skeptics or climate deniers, whatever you want to call them, who were saying, "Oh, the scientists are always over predicting and it never comes true," and all of that. There are some kinds of predictions, yes, where that has happened, but by and large, it's gone the other way. And glaciology, sea level rise, ice sheet melting is definitely, they've been under predicting the rates. And one of the things that's happened is ice loss from the Greenland ice sheet increased sixfold from 34 gigatons a year to about 215 gigatons a year between 2002 and 2011, I mean. Antarctic ice loss more than quadrupled from 30 gigatons a year up to 147. These are enormous changes. This is not linear at all. Scientists are very confident that global mean sea level will rise at least 8 inches, but no more than 2 meters by 2100, depending on the decisions that we make, okay? So to kind of look at this a little more, multifactorial causal graph. If you just kind of go, say, when we started getting the components of thermal expansion and meltwater, and the addition of those two being this one up here, if we kind of start in where we had data, so about 2004 or so, when we started having that, you can see the contribution that each of these made, and they were roughly the same in 2005, not that long ago. All of you were born. And meltwater is now the big story, okay? So when you add the two together, you get this kind of rise like we're seeing. All right, now going back to that sheet again, something to think about. Higher background water levels mean that deadly and destructive storm surges, like those associated with Hurricane Katrina or Superstorm Sandy, push farther inland than they once did. Okay, and so we saw that a little bit in our reading of Man, didn't we? Where they talked about Superstorm Sandy, and because sea level is higher, there's a lot larger surface area in these coastal regions that becomes vulnerable to destruction. That's also true of Florida, by the way. Florida is a waiting disaster because it has so much of its territory just below sea level, or just above sea level, rather. Okay,